Hello, welcome back. Today we are going to talk about perfect competition. Perfect competition is the first of several different kinds of market structure that we usually look at in our economics course. Perfect competition is always the starting point of our discussion about market because perfect competition offers some fairly unrealistic, idealistic market conditions under which market outcomes appear to be very efficient and generic. And once we understand perfect competition, we can always go back to more realistic, more complicated, and more imperfect market structures, and we can understand how the real market works as compared to an idealistic market such as perfect competition. So perfect competition is a very important part of our theoretical discussion about market in economics. So we will start today with a definition of perfect competition. I want to sort of talk about perfect competition as a market where there are basically four characteristics. The first, and I think the most important of those characteristics, is that perfect competition is a market characterized by a very large number of buyers and very large number of sellers. Now, in addition to the buyers and the sellers being of large quantity, we also assume that our buyers and sellers have this atomistic sort of existence, which means that our buyers buy very small quantity compared to the size of the market. Our sellers sell very small quantity compared to the size of the market. Another important assumption about the market is that the market has perfect information, which means that the buyers and the sellers know everything that is happening on the two sides of the market. If a buyer changes their price, if a seller changes their price, every buyer knows about that change, and every other sellers know about that change. The last assumption, which we are going to really explore towards the later part of this chapter and discussion, is that we will assume that there is unrestricted entry and exit for firms in the long run, but no entry and exit for firms in the short run. In the short run, we want to sort of keep our market as it is and try to understand various properties of our market. Okay, so that's like the main four characteristics of a perfectly competitive market, and we have just talked about them by talking about the assumptions that the perfect competition market is made from. Okay, so if that is like the market we are talking about, we need to now understand about what kind of market power do firms have or buyers have in this market. It should be very clear that this is a market where neither the buyer nor the seller have any control over the market. Okay, so we have to understand that this is again an idealistic market where the size of the buyers are very large, the producers are also a large community, so a single buyer or a single seller really cannot control the market price or any other market activities. What is important is that we are going to assume, based on this idea, that both the buyer and the seller are price takers. So it is price takers, which is one of the critical assumptions about our perfect competition. If both the buyers and the sellers are indeed price takers, you can imagine that the type of goods that are being sold in the market and produced by the suppliers are going to be identical. Why? Because we have very large number of sellers they are engaged in intense competition with each other, and there is only they none of them really cannot control the market price, meaning that they really don't have any way to control how the buyers are going to buy their product. So the only way firms can really survive in this market is they produce goods that are identical to their competitors. So at least some buyers might be fooled into thinking that the good that a single producer is producing is as good as the good that other producers are producing. So the type of goods therefore will end up being produced in perfect competition are called homogeneous products, meaning that they are all identical. Okay, so market control, no control of the the buyers and the sellers have no control over the market. The goods being produced are homogeneous. The demand curve for this market will be standard. It would be a downward sloping demand curve, and the supply curve will be a standard upward sloping supply curve, and the intersection between them is going to determine the market equilibrium price and market equilibrium quantity. So the demand curve for the market and the market equilibrium are very standard, nothing fancy about that. What is important about perfect competition is that the demand curve faced by the market and the demand curve faced by an individual firm are not the same, and we need to really be careful about understanding it. Okay, so imagine, so let's try to understand the graph that we're looking at right now. Let's say that we have the market, market price determined by the intersection between the demand and supply curve. So our market price is $5, and which is determined at the intersection between demand and supply. Now imagine that a firm is trying to charge, thinking about charging a price, let's say, of $6. So the market equilibrium price is 5, so everyone is charging $5, but our firm is charging $6. Can he really do that? The answer is no, he cannot. Why? Because the goods that are being supplied and produced by each supplier are identical. So if firm A is charging me $6 but selling me the same good that firm B is selling to me but charging a lower price, why should I buy from the more expensive seller, right? So if you charge $6, you will be out of the business. So our firms really do not have any demand curve for any price over $5. Now what if our firm thinks that they can fool other competitors and start charging a cheaper price, let's say $4. At $4, what will happen is that because of the assumption of perfect information, all the other producers will also start charging lower price, and if all of them starts charging lower price, the market equilibrium price will actually go down. So, and if the market equilibrium price goes down from $5 to $4, notice that it's not good for anyone, right? Because everyone is charging a lower price than they otherwise would have got, $5. And if prices go down, our firms obviously make a loss. So it really doesn't make sense for our firm to charge a price lower than the market equilibrium price. So what we're gonna now do is make a very powerful conclusion. We're gonna say that our firm will not charge any price below the market equilibrium price. Our firm will not charge any price above the market equilibrium price. So the only price that our firm can literally charge is the market equilibrium price, which is $5. Now the trick here is that our firm is small compared to the size of the market. So at the market equilibrium price of $5, our firm really faces very large demand from a very large group of buyers. So we assume that the demand curve faced by our firm at the market equilibrium price is horizontal. It means it is perfectly elastic, meaning that at the market equilibrium price, if our firm can manage it, he or they can sell as much as the market is buying from them. So it's so they face like a perfectly elastic demand curve. So that's a very interesting concept. Also notice that for each quantity our firm sells, let's say from Q1 to Q2 to Q3, whatever, the extra revenue they get is equal to the price, right? So it means that price is equal to the marginal revenue of the firm. Every time a firm sells one additional unit, the extra revenue or the marginal revenue it gets is the price, right? So, so the price curve, which is the demand curve, is nothing but the marginal revenue curve for our firm. So what we do sometimes is that we sometimes write the demand curve for a firm as the marginal revenue curve, which because they are going to be identical. So that's interesting. Okay. The next task what we are going to do now is we are now going to think about profit maximization condition under perfect competition. How do firms maximize their profit? I want to start with a little bit about a little bit of mathematical formulation, which I think is constructive in the sense that the math is our friend, and math can give us a very concise expression about how profit is maximized. So imagine that profit is defined as the difference between total revenue and total cost. Profit is defined as the difference between total revenue and total cost. So it is defined as the way you are looking at it. So we will say that this expression, the difference between total revenue and total cost, is maximum when pi is maximum. Now in so there are various ways to interpret that. We are going to say our pi, the revenue profit, is maximum when adding any further output to the production process really does not increase profit. Okay, so sometimes this is called a first order condition of profit maximization, which says that if you increase your output by a very small amount of delta, the change in profit is actually zero. So that is this expression. So what we are doing is that we are essentially differentiating this expression on both sides. So the left hand side is delta pi divided by delta q. The right hand side is very instructive. It's the change in total revenue, first term, with respect to quantity, and the second term is change in cost with respect to quantity. The change in total revenue with respect to quantity is called marginal revenue, and the change in total cost with respect to quantity is called marginal cost. Once we simplify that, we find that profit is maximized where marginal cost is equal to marginal revenue. And since we know that marginal revenue is always equal to marginal cost, is equal to price in perfect competition, the equilibrium condition is that in perfect competition, price is equal to marginal cost, and that ensures that the firm maximizes their profit. Okay, so that's very interesting. What we have done is we have just defined what marginal cost is equal to marginal revenue actually guarantees. It guarantees that your profit is maximized. But in a minute we are gonna explore this idea of what maximum profit means for our firm in perfect competition. Does it mean that our firm always can earn positive profit, or can it earn negative profit, or what kind of nature of profit can our firm earn? Before we do that, I think this chapter puts a lot of emphasis on trying to understand these concepts from a graphical perspective. So the graphical illustration is going to be a major theme in this chapter, in this topic that we are going to move forward with. We need to really sharpen our understanding of graphical tools. So let us move on. Let us look at what this particular, how can we express profit maximization in the context of a graph. Okay. So I want to show you that there are basically two ways of graphically showing profit maximization. The one is where you are going to be using total cost and total revenue. So this is our first graph on the left. So let's focus on what this graph is telling us. We have some data. The data is about total revenue and total cost, and total revenue is a straight line. As you can see, total cost is sort of like a convex curve, and the difference between total revenue and total cost are the profit numbers, which is the last column. Obviously, if you want to maximize profit, you want to maximize this total this profit, or maximize the gap between total revenue and total cost. You should see immediately that the gap between total revenue and total cost is maximum when our firm is producing 10 units of output, where the profit is 29. Graphically, this output can be identified where the gap between the total revenue and total cost is the maximum. Let's try to understand this. Notice that at the beginning, our total cost is above our total revenue. So it means that in this region, profit is negative, meaning that there is an economic loss. And you can see those happening at the very initial stage of the production. Now, after production level of 4, you see total revenue sort of rising above total cost. So this entire region indicates different kind of profit opportunities. At a very high level, you will again see total cost rising over total revenue, causing the firm to again encounter a loss. So what we see is that in the production process, only a certain sort of range of output offers our firm some kind of profit. And a firm wants to maximize profit by finding the output level that maximizes the gap between total revenue and total cost, which is found at the output level of 10. Now what we can do, we can collect this gap between total revenue and total cost. We can define that as a profit function, and we can see that profit is maximized where this curve is maximum, and sometimes we say that profit is maximum where the curve sort of kind of flattens out, and you can see that, or the slope of the curve becomes zero at that level. So all of these are happening at the output level of 10. So by using the total revenue and total cost approach, we will find maximum profit when the gap between total revenue and total cost is maximum, where the profit curve reaches peak, and where the slope of the profit function is 0. So all of them mean the same thing. We can interpret profit maximization and graphically show that by also using a marginal cost, marginal revenue approach as well, and that is our second graph to the right. Now notice that our marginal revenue curve is a straightforward horizontal line, and our marginal cost curve is a U-shaped curve, something that we have learned before. Now imagine the range of output where marginal cost is less than marginal revenue. So this is an area where marginal cost is smaller than marginal revenue, which means that for each additional unit of output, the cost of producing that output is less than the revenue it brings our firm. So this is obviously a range where our firm is making profit, right? Okay. Then again, we can think about a region where marginal cost is greater than marginal revenue. you can see that marginal cost has actually rises over the marginal revenue. So if marginal cost is greater than marginal revenue, the extra cost of producing an output is greater than the extra revenue that output brings our firm, so our firm earns loss. So between a profit and a loss, we will find a situation where marginal cost is equal to marginal revenue, and at that level also turns out to be 10, where firms will maximize their profit. You can and so there are two ways of finding profit by using graph. One is when the gap between total revenue and total cost is the maximum in your left graph, or where the marginal cost is equal to marginal revenue in your right graph. So in summary, profit maximization will be found where marginal cost is equal to marginal revenue. And they also mean that when marginal cost is equal to marginal revenue, the gap between total revenue and total cost is maximum, and the profit of the firm is maximized. Okay, so that sort of covers the basic starting point of our discussion about how firms think about maximizing their profit. Now the question that now we are going to go even further, and we are going to look at different scenarios under which our firm can earn profit or firm can earn loss. And also we are, in that context, we are going to talk about what do a firm really think about when they are earning loss, right? Is earning loss means that a firm need to really shut down, get out of a market? The answer is no. And we are going to talk about this step by step. So stay with me. We want to talk about profit maximization in the context of two different time dimensions, short run and long run. And the reason of why the short run and long run are important in our discussion is because in perfect competition, we believe that in the short run, firms really cannot enter or exit from an industry. That is critical because even if you are earning loss in the short run, according to our market model, we believe that firm really cannot exit from an industry. You might argue that this doesn't make any sense, but think again, right? Imagine firms like I don't know, Sears or Radio Shack, who are making loss, quarter after quarter, but they're still staying in business. They're still taking time to sort of exit from the industry. So in short run, since our firms cannot exit from an industry, cannot get out of an industry, what should a firm do if it starts earning loss? This is obviously a critical question. We're going to try to understand this idea by looking at situations when a firm earns profit and when a firm earns loss, and how a firm responds to that. We will look at two different kinds of situations. We are going to look at something called a good time and a bad time. Okay, and I want to understand this, from a very general perspective. The most important idea about whether a firm earns profit or loss has got nothing to do with what price it gets from the market, or what is the marginal cost. What we should understand is that profit is nothing but the difference between the price our firm gets and the average cost of producing that good. Okay, simple idea. Let's look at our first graph on the left, active learning 2. In this situation, notice that our firm is getting a price of $10, and according to the profit maximization condition where PMC is equal to MR, our firm is deciding to produce 50 units. Now at that 50 unit, notice that the average cost of production of a firm is $6. You can go to the average total cost and find out that in order to produce 50 units, the average cost of production is 6. You should see immediately that our firm is earning profit. Because if you think about the price it gets $10 for every unit, and the average cost of producing each unit is $6. So on an average, our firm really gets $4 worth of profit. So the total profit is nothing but the difference between price and average total cost times the quantity. So you take the 4, multiply that with the quantity our firm produces, and the total profit is 200. This is a situation where our firm is earning profit. This is a situation where the profit is being earned because the price that our firm is getting is higher than the average cost of producing the output level the firm is planning to produce. What would happen if the average cost of production is higher than the price our firm receives? That takes us to the second example, which we are going to call bad days. So the first one was good days. The second one is bad days. Okay. So let's think about this. The same scenario again. The only difference is that our price is now $3. At price $3, our firm is thinking about producing 30 units. If it produces 30 units, the average cost of producing 30 units is 5. So you see that the price that our firm gets is less than the average cost of producing that unit. So our firm is clearly earning loss. So the per unit loss is about $2. It's between 5 minus 3, which is $2 loss, and then you multiply that by the quantity, and you get the total loss of the firm, which is 60. So this is the bad days example where the firm is earning loss because price is less than average cost of production. In the slide, in the lecture note, I also do a little bit of mathematical formulation. You can take a look at that, but that's not the point. The most important point is that the good days and the bad days for our firm really depends on where their average cost of production is in relative to the price they receive. The firm faces good days or earn profit when the price is greater than average cost of production. Our firm faces bad days or earns loss when the price is less than average cost of production. So that's interesting. Let's now think about a very, very interesting situations, and this is called a shutdown situation. Okay, so what is shutdown? Shutdown is a strange concept. Shutdown means that our firm really does not produce anything, but our firm really does not exit from the industry. They just stop producing. Shutdown is not a trivial economic concept because shutting down is an economically wasteful activity, right? You have machines, but then you are not producing anything. So why would you not produce anything? So let's try to understand the idea of shutdown systematically. First of all, our firm needs to believe that the loss they are incurring is temporary. If loss is temporary, our firm might decide to remain in the market, feeling that in the future this temporary situation could be reversed, firms could start earning profit. Okay, in that situation only, a firm might think about temporarily shutting down their production. Now, shutting down is a very critical economic decision which will involve, calculating the cost and benefit of shutting down. So let's try to understand the cost and benefit of shutting down. So the cost of benefit of shutting down the firm production is that a firm is going to lose their revenue. Okay. So if they do not produce, they cannot sell. If they cannot sell, they cannot earn any revenue. But then there is a benefit of shutting down. The benefit of shutting down is that our firm can save the total variable cost, the cost of buying raw materials, the cost of hiring workers. They can at least avoid those. They can save those. Okay? But you have to understand that they have to pay total fixed cost anyway. The total fixed cost is the cost of setting up the firm, which our firm already incurred before even production started taking place. Okay? Now, in the context of total fixed cost, I want to take a moment to really talk to you about this idea of sunk cost. Sunk cost is a very interesting economic idea. Sunk cost is a cost that has already been committed or cannot be recovered. So when you buy machines, when you set up a industry, factory, you pay rent on those, you pay the electricity fee, utility bills on those. These are what we call sunk cost. These are costs that you incur before entering into a production process. Sunk costs are cannot be recovered. So if they cannot be recovered, sunk costs should not be part of the decision making process of whether you want to shut down or not. Sunk costs should not affect your decision. Total fixed cost of a firm is sunk cost. It cannot recover that. So when deciding whether our firm needs to shut down or not, total fixed cost should not come into the picture. So the idea is very straightforward. A firm will shut down if the total revenue cannot even cover the total variable cost. A firm will shut down if the total revenue it earns from selling the good cannot cover even the total variable cost. When we divide both sides by Q, we get total revenue divided by Q, which is average revenue, and we get total variable cost divided by Q, which is total average variable cost. We know that in case of a horizontal demand curve, our average revenue is nothing but marginal revenue, which is equal to price. So the shutdown condition can be rewritten as that a firm will shut down when the price it receives is less than the average variable cost. When a price is equal to average variable cost, this is called the shutdown point. Shutdown point. This is a very important concept. The quantity at which price is equal to average variable cost is called the shutdown quantity, and the price at which the firm achieves the shutdown point is called the shutdown price. Let's look at this shutdown idea from a graphical perspective. Okay, so now let's look at the problem that we're looking at. Okay, there are some numbers which you can sort of look at yourself. Let's start with the situation that we have a market equilibrium price of $3, where marginal cost is equal to marginal revenue, indicates that our firm produces 7 units. When the firm produces 7 units, the price it gets is 3, and the average total cost it receives, it incurs is $5.14. So obviously it is earning loss, right? But notice that at this quantity level, the average variable cost is also $3, which means that at that point, the shutdown point, price is equal to average variable cost, and that is the shutdown condition, shutdown point for our firm. If prices fall anything below $3, where price is equal to average variable cost, a firm will shut down. Okay? So this is very interesting. Now, the discussion of shutdown also leads to a very interesting concept where we are now going to talk a little bit about the supply curve of a firm, right? So far, we were talking about the demand curve a firm faces, which is kind of strange idea because when we think about firms, we always think about their supply curve, and we really haven't defined what the supply curve of a firm is. So let's go ahead and do that. Okay. Now let's try to understand that the supply curve of our firm is going to be quite strange. Why? Because imagine that we are in a situation where the marginal cost curve and the marginal revenue curve is kind of standard, and as prices rise, let's say when the price was P1, all our firm was doing is that it was going to the marginal cost curve and figuring out how much it wants to produce. When the price rises to P2, it just goes to the marginal cost curve again and find out how much it wants to produce. So therefore, how much our firm really wants to produce can be traced along the marginal cost curve. As price changes, points on the marginal cost curve really tells you what output our firm is going to be producing. So we can get a sense that our marginal cost curve can be interpreted as the supply curve for a firm, with some important exceptions. Now notice that for a price, let's now move to the second graph to the right. When price is greater than average variable cost, meaning that when price is anywhere above this shutdown point in this region, as prices go up, quantity goes up. As price goes up, quantity goes up, so we have law of supply. So this is the supply curve of a firm. The upward sloping part of the marginal cost curve above average variable cost is the supply curve. But for any price below the average variable cost curve, there is no supply curve, because our firms do not sell anything, our firms do not produce anything, our firms shut down. So the supply curve of a firm is therefore has this strange shape, is that below the average variable cost curve, our supply curve is non-existent, and after that, for any price above average variable cost, our supply curve is nothing but the marginal cost curve for our firm. Okay, so that's interesting. Let us now move our attention to the other kind of time dimension, which is called long run. We have talked about long run before. Long run is a situation where firms have more flexibility of making their decisions. In a more general context, long run is a situation where firms really can buy machines, they can expand their production, so on. So in our perfect competition context, long run is where firms can enter or exit. Both of these are possibilities. As we are going to show in a minute, that these two important economic activities really change the market dynamics in the long run. Okay. Most importantly, we are going to show you that in the long run, the only kind of profit that our firm can earn is actually zero economic profit. That's a very interesting idea. Okay. So let's now talk about entry and exit in the long run. So why would firms want to enter in an industry in the long run? Okay. Probably if the industry is earning profit, then firms will probably want to enter, saying that profit is there. But as soon as firms enter into a industry that was earning profit in the short run, firms' supply increases because new firms are entering. That reduces the price. If prices go down, profit actually goes down. So entry really causes prices to go down in the long run. What about exit? Why do firms want to exit from an industry? So that should be obvious. Firms will be exiting if the firms incur losses. So when firms incur losses, they leave the industry. As a result, supply goes down. As supply goes down, prices go up, profit goes up. That's also interesting. So exit in the long run causes profit to go up, prices to go up, and profit to go up. Now, we should see that there can be all these movements in the long run whenever there are losses or profits in the short run. As long as profits are there, firms are going to continue to enter into an industry, causing a lot of locomotion on the supply side. as long as there are losses, firms are going to leave the industry, causing a lot of locomotion in the supply side. This cannot be an equilibrium. The only equilibrium that we are going to see in this market is where firms stop entering or exiting from an industry, and that will happen when firms are in the industry are earning zero profit. Zero profit. Let's first define the long-run equilibrium condition. The long-run equilibrium condition says that a firm in the long run earns zero economic profit. Zero economic profit can be earned when firm's price the firm receives is equal to the average total cost. Very simple idea. Now we know that in the perfect competition, price is always equal to marginal cost. So it means that in the long run, profit maximization happens when MC is equal to average total cost. But then we have learned something else in the previous chapter, where we learned that our marginal cost curve really intersects our average total cost curve at the minimum point of the average total cost. So marginal cost is equal to not only equal to average total cost, but it is equal to the minimum average total cost, right? So if we combine all these ideas, our long-run equilibrium condition is that price is equal to minimum average total cost, and that guarantees that firms earn zero economic profit and there is no more entry or exit from the industry. Let's now try to understand this from a graphical perspective, because graph is very important for our understanding of long-run market conditions. Before we do that, I want to spend a little bit of time trying to give you intuition as why zero economic profit is a long-run equilibrium. So we are saying that in the long run, our firms earn no profit. So if our firms do not earn any profit, why would firms want to produce? The explanation lies in the fact that our economic profit includes all the costs. It includes all the costs like your opportunity cost of your time, your manager's salary, so on and so. So if you are the owner, you also incorporate your time cost, your own salary in the cost structure, so that although you are earning profit, zero profit in the long run, you are still being paid for your time and you are still being paid for your effort and everything. So accounting profit actually is positive, although economic profit is zero in the long run. So it makes perfect sense that even in the long run, even when firms are earning zero profit, they're still staying in business and the market is in equilibrium. Let's now look at our long-run equilibrium from a graphical perspective. Now, before we do that, we want to also spend a little bit of time trying to look at the long-run market supply curve, which again is going to be different. Notice that in the long run, equilibrium is found only at one point. This is a point where price is equal to the minimum point of the long run average total cost curve. There are no other price that is relevant in the long run. There is no other quantity that is relevant in the long run. Now for the market, therefore, at that price, the supply curve is horizontal, meaning that for a firm, one firm or all firm together, they can supply unlimited quantity of output in the long run at that price and still earn zero economic profit. Okay, so that's that. Let's now do two very important experiments. Okay, the experiments that we are now going to look at is going to try to give you a very visualized idea about how entry and exit really causes changes in the profit of the industry, but at the end causes firms to earn zero economic profit in the long run but still achieves market equilibrium. So our experiment will start, and you can see that in the graph. So let's start with the situation that we are looking at the firm and we are looking at the market. Let's assume that the original market equilibrium is at A, where the original demand curve and original supply curve is intersecting. that derives a market equilibrium price of P1 and a market equilibrium quantity of Q1. At P1, notice that our firm is earning zero economic profit, because at price P1 the price is equal to the minimum average total cost, so our firm is earning zero economic profit. So that's our starting point. Suddenly there is an increase in demand because of some kind of change in taste or whatever. If that happens, our equilibrium changes from A to B. Market equilibrium quantity increases from Q1 to Q2. Market equilibrium price increases from P1 to P2, which means that the market altogether is now producing more. At P2, notice immediately that our firm now has profit. At P2, which is the higher price, the average cost is about here, the price is here, so this rectangular area measures the profit our firm is earning in the short run as a result of this increase in demand. Okay, are we all clear on that? Okay, good. So when there is profit, this profit is going to cause entry into the market. New firms will try to come to this market because they are seeing profit, and when they enter into this market, supply curve is going to shift to the right. Is going to cause more supply of the same goods being coming to the market, and the market equilibrium will move to C. So market equilibrium was originally at A, then it moved to B, then it moved to C. So at the new market equilibrium C, notice that our price have gone down to P1, quantity has increased. What does that mean? It means that our individual firm still faces the same price, and at the original price of P1, our firm is again earning zero economic profit. Okay, so notice what just happened. The market was at equilibrium when firms were earning zero economic profit. Then demand increased, caused market to earn profit in the short run, which caused entry in the long run. As a result, supply increased, and as a result, profit started going down because price went down. This process ended where the market price reached back to the original level at P1. Firms again started earning zero economic profit. So it should be clear that A and C, these 2 points, A was the original market equilibrium, C is the new market equilibrium, indicate the same equilibrium price of P1 at which the firms were earning zero economic profit before. They're also earning zero economic profit now. Okay. So this was a situation where there was short-run profit which caused locomotion in the market, in the sense that supply went up and caused all these changes. Now we're going to look at another situation where there is loss in the short run, and that will cause exit for firms. So please stay with me. I'm going to draw this one for you so that we sort of sharpen our understanding about graphical tools. Just like the previous one, I'm going to draw two large graphs. One is for the market and the other one is for the firm. So this is firm, this is market. We are going to start with a situation where the market is in equilibrium and the firm is facing a price of, let's say, P1. At that, let's assume that the demand was D1, supply was S1. Let's call that point A. At that P1 price, we are going to assume that our firm is earning zero economic profit. So this is where marginal cost and average total cost was also intersecting. So let's imagine that the original market equilibrium quantity is Q1. So that's where we are starting. Now suddenly imagine that for some reason demand goes down from D1 to D2. Okay, so demand shifts to the left. If demand shifts to the left, we have now equilibrium with the original market equilibrium with the original supply curve, where market equilibrium price now goes down to P2, market equilibrium quantity goes down from Q1 to Q2. Okay, So for a lower price, let's just put this guy a little bit upper so that we know. So at this lower equilibrium price of P2, we now know that our firm is earning loss, and the loss is the area, is this area. So at this P1 price, let's say our firm is producing Q2, but at that price the average cost is higher, so we see an area of loss. So this is our loss. Okay, so when there is a loss, firms, so we really do not know whether our firm is going to exit from this industry, right? Because we haven't drawn our average variable cost, and it could be that our firms could shut down. It could be that our firms still produce at that level. So, but one thing is clear, that whenever prices go down below P1, our firm is going to earn loss, and this loss in the long run is going to cause exit, meaning firms will go out of this industry. When firms start going out of this industry, supply will go down. As a result, supply curve will take a leftward shift. So in the short run, our market equilibrium went from A to B. I should have drawn that a little bit careful, so let me do that. Our original market equilibrium was at A, our new market equilibrium was B. Now as supply curve shifted up, we have intersection between the new supply curve and the new demand curve, and the market equilibrium is happening at C. At C, notice that the original market equilibrium price is restored, P1. So at P1, this profit, this loss that firms were earning disappears, and the firm is again earning zero economic profit at P1. So what happened? We started with point A, where the market equilibrium price was P1, our firm was earning zero economic profit. Then demand shifted to the left, causing equilibrium to go from A to B, causing prices to go down. When price went down, profit became loss. Firms were earning loss. That loss created an exit situation for the firm, where when firms were exiting, supply curve was shifting to the left. As supply curve shifted to the left, we find a new equilibrium at point C, where the original market equilibrium price is restored. At that restoring price, we have our new long run market equilibrium. So just like the profit case, we saw that in this case, when there was loss, it caused locomotion in the market, where some firms were leaving, but eventually market came back to equilibrium, where firms were again earning zero economic profit. Okay, I have kept some space in the document that I am uploading along with this video. Please try to use that space to draw whatever I have drawn so far. I'm going to conclude my discussion today by looking at three different situations. An example where we can use these graphs to really get a very deep understanding about how firms are making profit or loss. Let's start with figure number 1A. Right? In figure A, notice that the market equilibrium is found where marginal cost is equal to marginal revenue. So the price is 10, the equilibrium quantity is 100. At that quantity, notice that the market price is 10, average total cost is 8, so there is a profit. So profit per unit profit is 10 minus 8, which is 2, and the total quantity the firm is producing is 100, so we can literally calculate the profit of the firm, which is 200 in figure A. In figure A, firm is earning profit. Okay, let's look at figure B. In figure B, notice that the market equilibrium is found again at a point where market equilibrium price is 10, market equilibrium quantity is 100, but now at this quantity the average total cost is also 10, which means that our firm is making no profit at all. Our firm is making zero profit in case B. Let's look at case number C, figure C. Figure C, we find equilibrium where again the market equilibrium price is 10, the market equilibrium quantity is 100. At this quantity, equilibrium average total cost is about 13, which means that clearly that our firm is earning loss. Okay. Now whether the firm is going to shut down or not cannot be said at this point, right? Because our average variable cost curve could be like this. It could be below the market equilibrium price, and then our firm could earn loss but still continue to produce. But if, let's say, our average variable cost is also higher than the marginal, higher than the price, then it could be realistic that our firm could shut down, but we really don't know. One thing is sure, that as long as average total cost is higher than the price, our firm is surely earning loss, and that sort of concludes our discussion about perfect competition. So what we have done in this discussion, hopefully, is that we have provided you with a general view about what perfect competition is. We started with some definition about some assumptions about the perfect competition. Then we showed you equilibrium conditions under perfect competition. We saw that the demand curves have certain interesting properties about in the perfect competition. Then we looked at profit maximizing condition in the short run and in the long run. In the short run, profit maximizing condition is that price is equal to marginal cost. In the long run, profit maximizing condition is that price is not only equal to marginal cost, but it is also equal to the minimum average total cost, which means that in the short run, our firm can earn either loss or profit. In the long run, our firm only earns zero economic profit. So I hope that this lecture was helpful to you. If you have any question, please get in touch with me. Thank you very much.